Students, in this video I am going to explain SP2 hybridization. SP2 hybridization means the intermixing of one s orbital, this is pure s orbital, and two p orbitals, one s orbital and two pure p orbitals. One s and two pure p, the combination of one s orbital and two p orbitals, these are three, so they produce three hybrid orbitals which are like this: one, and this is second one, two, and this is third one, three. So this is SP2, this is also SP2, this is also SP2. These three SP2 hybrid orbitals will be arranged in the manner like this. So this is SP2, SP2, SP2. So these SP2 hybrid orbitals are arranged in which manner? This is trigonal planar. So this is trigonal planar. Structure, and the bond angle is 120 degrees. So one s orbital and two p orbitals intermix together to form three sp2 hybrid orbitals which are arranged in trigonal planar manner with bond angle 120 degrees. So example 1. First example is BCl3, boron trichloride. In boron trichloride, central atom is boron. Boron atomic number is 5, configuration 1s2, 2s2, 2p1. 1 means this is first level. These are 2 and 2, so this is second level. So second level contains s orbital and p orbital. In s orbital we are having 2 electrons, and in p orbital we are having 1 electron. So after excitation, electron jumps from s level to p level, that means from here to here. So the hybridization will be like this. So S and 2p, that is sp2 hybridization. So in BCl3 the central atom is boron. Boron undergoes sp2 hybridization. sp2 means 2 plus 1, so 1s and 2p, so total 3 orbitals. So they will produce 3 sp2 hybrid orbitals. So with these 3 orbitals, chlorine will come. Chlorine with atomic number 17, configuration 1s2, 2s2, 2p6, 3s2, 3p5. So it is having p5 electrons. 1, 2, 3, 4, 5. So pz. So pz orbital is ready to overlap with sp2 hybrid orbitals. So boron is in sp2 hybridization. Boron undergoes sp2 hybridization. sp2 hybridization means 3 sp2 hybrid orbitals. These are the 3 sp2 hybrid orbitals Each orbital contains one electron each. So each orbital contains one electron each. With these unpaired orbitals, pz orbital of 3 chlorine atoms. This is pz orbital of 1 chlorine atom. This is chlorine. This is another pz orbital of third chlorine atom. This is another pz orbital of second chlorine atom. So 1, 2, 3, 3 chlorine atoms. So the shape of the molecule is trigonal planar. Shape of the molecule is trigonal planar, and the bond angle is 120 degrees. So in this molecule, this is SP2, SP2, SP2. This is PZ, and this is PZ, and this is PZ. So there are three SP2P bonds. So there are three SP2P sigma bonds. So the shape of the molecule is trigonal planar. Trigonal planar. And the bond angle is 120 degrees. So another example is C2H4. So C2H4, in C2H4 the central atom is carbon. Carbon atomic number is 6, configuration 1s2, 2s2, 2p2. 1 means first level, 2 means second level. So this is first level, this is second level. Second level contains, s orbital contains 2 electrons, and p orbital contains 2 electrons. After excitation, s electron jumps from s orbital to p orbital. So s1 and p3. So carbon contains 4 unpaired electrons, 1 in s orbital and 3 in p orbitals. So the shape of the molecule is like this: C2H4. So in this molecule, we are observing 1, 2, 3, 4, 5. 5 sigma bonds and 1 pi bond. So for 1 pi bond, we have to leave 1 electron from right side. We are not entering this orbital into hybridization. So we are leaving this orbital to explain about pi bond. So for pi bond, we are leaving 1 orbital. So hybridization will be like this. So hybridization is S and P2. So hybridization is SP2 hybridization. So in carbon, sp2 hybridization will occur. So that means carbon sp2 hybridization 1 and 2 and 3. So sp2, sp2, sp2. So each carbon is having one unhybrid orbital. So I am drawing unhybrid orbital like this. So this is unhybrid orbital. So each orbital contain one electron each. 1, 1, 1, and 1. So, and in CTH4 there is another carbon. So in another carbon also hybridization will be same, sp2. In another carbon also sp2 hybridization. The second carbon also contains one unhybrid orbital. So for that one unhybrid orbital, I am representing like this. So this is unhybrid orbital. So all these orbitals contains one electron each like this. So 1, 2, 3, 4. So with these orbitals which are having one electron each, four hydrogen atoms. Hydrogen, this is s orbital, this is hydrogen, and this is hydrogen, and this is hydrogen, and here also hydrogen, s orbital of hydrogen atom. So initially what happens, initially this one sp2 and this is also sp2. So sp2 sp2, so 1 sp2 sp2 sigma bond will be formed, and here sp2s, so this is sp2, this is s, so this is also sp2, this is s, this is sp2, this is s, this is sp2, this is s. So 4 sp2s sigma bonds will be formed. Finally, this is unhybrid, that means pure. This is also unhybrid, that means pure. So these two orbitals sideways overlap to form one p pi bond. One p pi bond. So in this structure, we have one sp2 sp2 sigma bond, 4 sp2s sigma bonds, and one pi bond will be like this. So one in this structure we have 1 2, this one 3 4 5 sigma bonds, that means 4 plus 1 sigma bonds, 4 plus 1 5, and this one is pi bond, so 1 p pi bond. So to calculate number of pi bonds, sorry, number of unhybrid, number of unhybrid orbitals equal to number of hydrogen atoms plus 2 into number of pi bonds, that equal to number of hydrogen atoms are 1 2 3 4. So 4 plus 2 into number of pi bonds will be 1. So 4 plus 2, that equal to 6. 6 pure orbitals or 6 unhybrid orbitals will be there. So let us calculate. So 1 2 3 4, 4 s orbitals are pure. This one is pure and this one is pure. So there are 1 2 3 4 5 6. So 6 pure orbitals are there. So pure orbital or unhybrid orbitals calculation. Number of unhybrid orbitals equal to number of hydrogen atoms plus 2 into number of pi bonds, that equal to number of hydrogen atoms are 4 plus 2 into number of pi bonds are 1. So 4 plus 2 into 1, that equal to 6. So in this structure we have 6 unhybrid orbitals, and the number of hybrid orbitals means in this it is sp2 hybridization, in this it is sp2 hybridization. sp2 means 3, sp2 means 3, so 3 plus 3, so total number of hybrid orbitals are 6, and total number of unhybrid orbitals are also 6. In this structure also, the shape of the molecule is trigonal planar. The shape of the molecule is trigonal planar, and the bond angle is 120. So bond angle 120, shape of the molecule is also trigonal planar. So finally, if any molecule undergoes sp2 hybridization, the shape of the molecule will be trigonal planar and the bond angle is 120 degrees only if there are no lone pair of electrons. If there are lone pair of electrons, the shape will be changed. So final conclusion is, if any molecule or in sp2 hybridization, the shape of the molecule is trigonal planar and the bond angle is 120 degrees.